Now moving to the second section of exploratory data analysis, which is the sanity check. So during the sanity check, it's the initial and the basic steps to take to become more familiar with the data and also define the structure and the quality of data. In this section, we're going to use Python to do the following. First, we're going to see how can we load the data using Python. We're going to check the data type. We're going to ensure the data integrity, and then check if there is any duplicates in this data, check if there is any missing data, and then after that we will do a check of outliers. Like I mentioned before, it's the list of the basic steps that we follow so we can actually make a couple of checks to make sure what is the quality of the data we are working with. So now let's start with this hands-on with Python to run a sanity check and this data. So the data I already uploaded this data in my notebook. It's a cars data, it's in CSV format. It depends on where the data exists. My data, it's in Excel format, so I already upload the data here in my notebook. But if, for example, you are working with a data that exists somewhere in another database, so in this case, you have to run maybe a connection between your notebook and this data source. But for this example, we are using a CSV data, and this is what we're going to be using in this sanity check exercise. So the first thing here is importing the libraries that I need for this sanity check. So the first thing is Panda. Also, I need NumPy, I need Seaborn, and also I need Matplotlib library because I may actually need to do some visualization. We're going to see later for each library what kind of function we're going to be using. So the first thing here, and before I go into any analysis or check, is to actually load this data. So since, like I mentioned, my data is in CSV file, so I'm gonna use the read CSV function, which is a function in Pandas library, to read that data and put it in a data frame, which I give it a name of df here. So now if I run the code, this is going to import the data from the Excel sheet and put it in this df, which is in a table format. Now let's say I wanted to review this data. As a first step, if I import or I load the data, I need to see what kind of data I have. So here I run the function head. The function head gives me the 5 first rows in this table or a data frame. Now let's say I wanted to look at the last maybe or the bottom of the data frame. I can use the function I have here, which is the tell. And then if I want to see exactly 5, I can just put the number 5. If I want to see more, maybe 8 or whatever number of rows I need to actually get, I can just change the number here. But now let's go with just having a number 5. So here, this is gonna give me the 5 last rows that exist in this data frame. So looking at this data here, the first thing is I need to look at the columns I have in this data. So here I have the make and the model. So this data, it's a cars data. So I have the make and the model of the car. I have the year of the car, and then I have some other information about this car, like the engine fuel, the cylinders, the transmission type, the number of doors, the market category, it's a luxury cars or what kind of cars, the size of the vehicle, the style, and also some other maybe information like the highway, maybe like a speed, and then how popular this car is. So there is like a list of columns I have that actually explain or maybe describe this specific car. So this is the data I have here. So again, in this phase, if I'm not familiar with whatever column exists here, and I'm not sure about what kind of information this column actually has, I need to do research, search maybe like online about what is the specific feature within this column, or maybe I go and I ask a business team if I'm working with a team that actually can help providing some information. So now let's move to the second part of the sanity check, which is checking the type of the data, because I wanted to make sure that each column has the exact or the correct data type. In general, I have two data type, which is numeric, for example, the number of doors, it's a number, or actually I have a categorical data type. For example, here, the market category, or the engine fuel type. This is like a category. So this is the two kind of data type I can have in my data, which is either it's a numeric data or a categorical data. Now for the numeric data, I have continuous or discrete. So the continuous is a type when my data it actually has a number that actually increase within a specific range, or take a value within a range. For example, here it's maybe the time taken to complete a specific task, or actually the volume of water. So here we're talking about a numeric number that's actually within a specific range. Or it could be a discrete number, which is the number of books in a specific shelf. This is not a continuous number. Or it could be maybe the amount or the number of employees in a specific company. Or it could be like the count of computer in an office. So this is actually a two type of numeric column. So it could be a continuous number that actually can take any value within a range, like the height, the weight, and temperature. Or it could be a discrete number which can only take on a specific value, which is the counted value. So if you want to remember the difference between the two, just remember that for continuous, it takes a value within the range. And here remember the height, the weight, and the temperature. Or a discrete number because it's counting number. It's something that you count. So the number of employees, the number of students, the number of doors, this is all discrete number. Now we move to the categorical numbers. The categorical could take two types. So it could be like a binary number, which is yes or no, true or false, or it could be ordinal. For example, like the example we have before, which is the engine fuel type. For example, this is not a yes or no value, but it's actually a categorical data type or information. For example, could be good, better, best, or it could be something like first, second, third, or could be like we mentioned before, maybe a music type, anything that actually not binary, it has an information, not just a yes or no, 1 or 0, true or false, this kind of information. So overall, this is the two type of data we have. So now let's check, how can I actually check if there is what is the data type of my columns. So I can run this function here, which is dtypes, and for the df I have, for the data frame I have, so this function gives me each column I have, each feature, and then it gives me the type. So if I have floats or int, this is a numerical value. Then if I have an object, this means that I have a text value, which actually I can convert this information to a category. If I want to give each type, each column here a specific type. I can take this each column that has the object and then just convert this column to a category type, which is we're gonna do here. So if you look at the driven wheels, it's an object, but let's say I wanted to take that column and convert it to a category type instead of having the object. So here I can use this function, which is as type. As type, if it's a function that actually I can use it to actually convert any column to a specific data type. So I can just call the column within that data frame and then call the function as type, mention that I wanted to convert this to category, and then put this information back to the column again. So I'm changing the existing type of the column with the new type. And then if I go and I run this is supposed to actually change my type. So if I go and I run the D type again, and then I check the driven wheels, I can see here that this changed from object to actually be a category. So this is a method to change the type of a specific column. So now let's move to a second part of the sanity check. Now we loaded the data, we checked the column, also we checked the type of these columns, and now we're gonna do more investigation to the data. There is a couple of columns, to function that you can run to actually investigate the data. The first one is describe. So this describe function, which is a function that you can run in all the data frame or just for a specific maybe column, but running this in the whole, it gives me the calculation or the statistical calculation for each column. So it gives me the counts within, like how many information or how many value I have within that column. It gives me the average, the standard deviation, the minimum value, the value within the 25%, 50%, 75%, and then the max value within that column. There is another section coming and how actually within the univariate analysis, we're going to go through this more. We're going to go through the definition of standard deviation, of the count, of the mean, the mode, the median, all the statistical measurements. So we're going to go through this more and during that section. But for now, just remember that in order to get this information, maybe like an easier way, it's to call this function describe, which actually gives me all this information for each column. Now let's look to another function that actually we can use to get information from this data, which is info. Info, it's a function that I can run into this specific data frame and then get some information about this data. Some information that I can extract from info is it gives me like the number of data I have, like the counts of the non-null value in each column, and also it gives me the data type for each column. So actually info, I can get more information within one function, so I can get the data type of each column and also get the number of the counts of the values within each column that is actually different than 0. This is also some of maybe the method that we can use to check if there is any missing data, any null value within a specific column. We can take the example here. If we look at the market category, you can see that the number of the count of the non-null value, it's actually just 8,172. It's less than the count of all maybe the rows we have, which is this number here of 11,916, which means that actually this column, it's missing value, or it has some missing values. This is the idea here behind this non-null count. Another thing here, if I wanted to investigate the data, but this time I wanted to run this within the column itself, it's actually to run the value count. So the value count, this method, if I run it, I choose, for example, this column, vehicle style. And then if I run it, this is going to give me for each value or each category of vehicle style that exists in this data, and then the counts, how many times this type or this category was repeated in this data frame. For example, if I have the sedan, this information is actually was repeated 3048 times over all the data frame I have. So this is a very also important function because it gives me an idea about what are the unique values that exist in a specific column, and how many times I have this this value actually exists in that column. Think of it if you have a column that actually shows maybe the gender, and then for you, your data has to be mixed between female and male data, for example, and then you run this, and then you found that maybe 95% of your data is just a female, and then you have 5% of male. It means that the distribution here, it's not what you are expecting. So this is like some small basic check, but it gives you some like understanding about your data, and you can react quickly when you get this actually finding in your data. I think also another method to use in a level of the column, it's the unique. The difference between count value or value counts and unique only gives you the unique values, the unique categories or values actually within the specific column, without giving you the number or the frequency of how many times that specific actually value exists within a DF or a data frame. Now let's say you wanted to just look at within all the data frame, you wanted to just extract two columns, and then maybe you review these two columns. Something that you can run is it's to call just the two columns, and remember this is the structure here of calling two columns within the same data frame. You can actually take this and maybe create a new data frame and just give create a new data frame just for this column. So you can, for example, call this a DF analysis, and then you can just run this. This is going to give you maybe a data frame that has just these two columns. So if I go again and then I run it, and maybe I run it with the head so I can see just the first 5 rows, this is gonna give me just the 2 columns that I wanted. So actually I created a new data frame from the existing data frame, so I can run whatever analysis I want just for this new data frame. We saw before unique, so again here just applying the unique for the years, so I can see how many years I have. Another thing that I can do here is if I wanted to create a data frame but a filtered data frame, I'm just interested in creating a new data frame from the existing one but with some specific condition. So here I can call the DF again, and then for the column that I have the filter in, for example here I want to create a data frame that has only the cars of the years after or superior than 2011. So here I can create a new DF just for those cars, and this is how I can. So I call the DF again, and then I put the condition here within that specific column of DF year. Then if I run this, and then I would just want to check the new data frame, I can see that all the year here, they are superior than 2011. Let's say I wanted to, as a part of this analysis, I wanted to create a new column and give it a specific value, and based on analysis that I'm making. So maybe I wanted to just for all, maybe the rows that they have a year that is superior to 2011, I create a new column, and I call it new column, and I give it the value new, meaning that all the cars after the 2011 are maybe new cars. I wanted to create this column, maybe I'm thinking to use it next on my analysis. So in this case, I use a function called log. What log is doing here, it actually goes and log these rows within the condition I have here, the year that is superior than 2011. And then I'm creating a new column, and just for these years, when the years is actually superior to 2011, I give them the value new. So if I run this, and then maybe I run just to check, because here I created a new column. Here I just wanted to filter the data, just look at it without actually making any updates. If I run this, and then I check that I have a new column here, and it has the value new for all the data that has the year after 2011. So now let's say you wanted to actually sort a data frame. You wanted to sort this data frame based on the year. So one of the functions that you can use is sort values. So sort values gonna give you the possibility to actually order or put in order a specific GF or data frame based on a specific column. So here I choose to order or sort my data frame based on the year. This argument here, which is in place equal true, it means that I'm actually sorting and applying this change on the existing GF in the same time. So here, once I run this, this is gonna give me the DF now starting from 1990 as the year to actually maybe the last year. Now, after I change the order of the DF, I can see that the index, it's actually, instead of starting from 0, it actually didn't change the old index. So whatever they put, the sort value actually puts this information or put the rows within the order by year, but actually it didn't change or did a reset of the index, so I can have the index again started from 0. So if I want to have this, I can use another function, which is a reset index with drop equal true. So let's see how this is actually work. So once I apply this, I can see that the index now it started from 0. Why the drop equal true? It's because I wanted to drop the old index and create a new one. So now moving to another part of this sanity check, which is ensuring the data integrity. So the data integrity is just to check that actually some information and the data are making sense. For example, if I have a column that it's email that actually contain emails, I have to check that the emails it's in the correct format. Maybe check that the columns are in the correct name and format. It's a list of an overall check-in of the data, so I can make sure that everything actually it's making sense. So let's take an example here. For example, the first thing is I wanted to check the columns. So if I want to just see the columns that I have in data frame, I can call the function columns, and this is gonna give me the list of columns I have. So if you can look at these columns, the first thing here, I see that there is a column called make and model, which means that this column actually contains both information. It's the make and the model. So maybe here I can think that maybe it's better to have two columns, and then instead of having one column that contains both information, I can just maybe have each information in a separate column. This is one. Another thing also, there is some information or some columns that maybe I don't need for this analysis. Now, if I decide that there is some columns that I don't need them, I can decide to actually drop this column. So let's say I wanted to drop some columns like the engine, fuel, for example, the market category, and others. So what function actually I can use in this case? So we can use a function called drop. So in this function drop, I can give it the list. This is a list format of all the columns, and then the axis equal 1, because I am dropping the columns within the axis 1. It means that it's in the column axis. So if I run this function here, I'm gonna run it, but also I will assign after the GF, after I drop the column, I assign this to the existing GF. So I'm changing the existing GF. So if I run this line, so this one, it's not gonna give me any output. So now I'm just gonna go and read the GF now after I did the drop of these columns. So here you can see that I have less columns in this data frame after I dropped all the other columns, maybe because I decided that I don't need them for this analysis. So there is really no need to actually keep them in the DF. It's make it the process much easier if we just remove some columns that we don't need. Now another thing that as a part of this check is actually I wanted to change the name or rename some columns, because some of them for me they don't make sense. For example, the engine HP, maybe I just wanted to give it like a simpler name like HP. Engine cylinder, I don't need the word engine, I just need to keep maybe the cylinders. There is a couple of things that's actually just gonna make my analysis easier if I change just or I rename some columns. So if I want to rename the columns, it's the same thing as drop. It's just a different maybe format to put the columns together. So I call rename function, and then I have to mention the columns, and within these columns I put the old name and then the new name. The old name of the column and then the new name I wanted to give to this column in the same format, and then run this code with the just generated maybe the first rows, and this is what it's gonna give me. So if I compare this with the previous DF, you can see that the HP now, the engine HP is just HP now, cylinder, it's much easier to read. And there is a lot of words within the column that actually I don't need to actually capture for this analysis. Now, back to what I mentioned previously, which is this make model column. Like I mentioned, this make model, actually it has the make and the model. together. So for my analysis, I wanted to create, or I wanted to separate this two columns, because in two columns, this information in two columns, so I can do some treatments for each, or maybe I need to run a specific analysis in each column separately. And especially that having them both together doesn't give me any information. So now let's say I wanted to just split the column. I can run a function called split. Now to create this, or to make this split, first I'm gonna call the column. In this case, it's the make model. And then because this column actually contains a string value or text, so I'm gonna call the object str, or to mention that this is a string. And then from here I call the function split. And now I have to say or mention what is when or from where I have to start the split. In this case, I have make, and then hyphen or hyphen sign, and then the model. So I wanted to make the split from that sign of hyphen. So this is gonna create for me two separate columns from that specific sign. And because I wanted to create two columns, I want to expand equal true, because I want to expand this split in two different columns from this sign that I mentioned here in the split. So running this, so if I run this, and then I'm just gonna go and call it to see what's actually gonna give me, it's actually gonna give me a data frame. So this data frame, it has a couple of columns. So I wanted to call the column 0 and the column 1. And this columns, it's what's gonna create for me the make and the model. So from here, I'm just gonna copy the code I created before. So in this position of 0, from the make model split, I have the make, and then from the same data frame and the column 1, I have the model. So here, if I run this, this is automatically gonna create for me this two columns, make and model. Now let's say I wanted to drop the existing column, which actually contain make and model together, because I don't need it. I can just call again the drop function with in place equal true, because I wanted to update the existing GF. And then when I call this the GF, the head, so I can see here that this creates for me two columns without the previous column. Now moving to another part of the sanity check, which is dropping duplicate rows. Imagine in your data frame, you have a list of rows that is actually repeated. So you don't need an information that is actually repeated multiple times within a specific data frame. This means that the value or the rows is duplicated. It doesn't add a value to your analysis. It's the opposite. It's gonna give you some values that they are all equal, but actually as a result, you may miss the information at the end. So you have to identify the duplicates and then maybe remove this duplicate, or choose how you're gonna do any treatment for this duplicates. So let's say first I wanted to, before I go and check if there is any duplicates, I'm just gonna check the shape of the data. So what's the function shape gives me is, it gives me the number of rows I have and the DF, and also the number of columns I have. So if I run the shape, the first number here is the number of rows I have in the data frame, and then the number 12 is the number of columns I have in the DF. So now let's say I wanted to check if I have any duplicates in my data frame. So to do this, I'm just gonna call the function duplicated. So this duplicated, I'm gonna call it within the GF or within the data frame. So this line here, or this section of code, it's gonna go within the data frame and filter the data frame to look for duplicates. Remember what we said before, when we wanted to create a new data frame from an existing data frame and we filtered the existing data frame to create a new one, it's the same thing. So here I'm gonna call the function duplicated, and this is gonna create for me the filtered data that has only the duplicated rows. Now I'm just gonna print the results, and I'm gonna just call the function shape for this new data frame so I see how many rows I have. So the shape function here for this filtered df gives me the value the same for the number of columns because it's 12, and then the number of duplicated rows it's 806, which means that there is a couple of duplicated rows in this actually data. Another thing also, before I move to actually maybe drop duplicates, is to actually check if what's the counts I have in this data. So if I wanted to check the counts, so for each column, what's the count of each column? I call the function counts. So when I called the function shape, the number of rows was 11,916. So some columns like the make and the model, they have the same value, and then there is other, maybe they don't have the same value, meaning that maybe they're missing some data, because remember the count is gonna only give me the non-null counts of data. Now I'm just gonna go ahead and drop this duplicate. To drop the duplicate, I'm just gonna call the function drop duplicate, and it's gonna take care for whatever duplicates I have within the GF, any duplicate rows. So if I call, after I drop the duplicates and then I call the head function, so nothing of course gonna change on the level maybe of the columns, but definitely now if I call the df counts, it's gonna change definitely the number of the counting of the values that exist. Remember for the make and the model, it was like around 11,900 something. So now it's 110. So this is the method that we're using to actually drop the duplicates. Now reaching maybe the final steps in the sanity check, which is a very important check. It's checking if there is any missing data. So during this notebook today, we saw that there is like a couple of functions that actually we can use, and they actually show that there are a couple of columns actually contain missing data. So now let's see if there is anything else that we can do to actually check if there is any missing data. One of the functions that we can use here is the isNull function. So this isNull function, it's actually return the value of true or false, meaning if there is a null value, it's true, and then if it's a non-null value, it's false. So with the sum, or actually with using the function or using the sum function, I'm actually calculating the sum of the null values. So here if I call this within my DF or data frame and print the results, I can see that for some columns they have null value. Remember for the make and the model, they have the exact shape of the whole DF or the number of rows, and we said before that they don't have any null value, and this is correct because they have a 0 value. But then there is other columns, like the column I created, it has 4,179 null value, and then I have others like the number of doors, the cylinders, also it has 32 null value. So definitely I have a lot of null value that actually need some treatments. So now there is a section coming when we're gonna discuss how can we actually create a treatment for the missing data within a specific data frame. But now let's just try some techniques that we can use actually to check for or to actually replace the missing data. One of the methods that we can use is actually filling the missing data in a specific column with the average value. So I have this column HP. So this column, it has 71 data or 71 one rows that is actually, it's null, doesn't have any information. Let's say I decided that I'm gonna replace those missing value with the average of that column, the average value of that column. So in this case, I'm gonna call the column, and then I'm gonna call a function called fillNA. So this fillNA, it's the same as the name, it's fill any null value that exists in the column HP. What this function gonna put inside of the null value, it's the mean of the HP column. So here I'm calling the function mean. So this mean in HP is gonna calculate for me the average value of the HP column, and then the fillNA function gonna take that value of the average and then replace it for the missing value within this column. So now if I go and I run this, and then I call the same function is null.sum, you can see here that the HP now is 0, meaning all the null value now is replaced with the average value. Another way maybe to treat the missing value is just to drop the values. But of course, deciding to drop the value, it means that you are taken from your data, and every time you take from your data, you are taken from the information. So remember this. So that's why it's very important to decide how you're going to replace your missing data before you really go with the decision to actually drop or remove these rows that have missing data. I think in the comment section, like when we discuss the treatments of the missing data, we're going to discuss this more. But this is here just to show you some techniques that we use to actually handle or do some treatments for the missing data. So let's say you decided that you're just going to go with drop-in. So we're just going to call dropNA, because this dropNA, it's actually drop only the null value. It's different than drop, because drop, it goes with whatever you want it to drop. But dropNA, it just is gonna go with whatever null value and just drop it and remove it. So let's apply dropNA and the df and then count the df. So here, if I do the counts, and maybe if I go with the df shape, it's gonna give me like a better like understanding if I know the shape. So the shape here, it's of all the data I have, it's 6,915 after I did all the drop-in of duplicates and everything. Now if I look at the count of each column, they all have 6,915, meaning all the columns now, they don't have any null value. And of course, if I run again the is null sum, all it's 0, meaning that there is no null value. Now, reaching the last section or the last maybe part of the sanity check, which is checking if there is any outliers. So first, before we go and we check how can we actually check if there is any outliers, maybe we'll go through like a definition of the outliers. So the outliers, it's information in the data that actually shows an extreme value within this data. It could be like linked to data entry, or actually it could be a fact. For example, I have like a factory of like milk. So we are producing milk, for example, and then every day I have an average of 10 10,000 liter. And then I have all this data saved somewhere. And then for one specific day, I had only maybe like maybe 5K or 5,000 liter of milk during that day. This could be like an outlier because usually we always get 10K. So this could be an outlier. This information, maybe if I keep this 5K, it's gonna maybe change a little bit on my analysis. So maybe I need to treat this information because it's unusual. It's not something that we have it every day. So this is an example. Another thing, let's say that we have a data of about maybe Texas states, and then I know that the average winter in Texas, or the temperature, is like a minus maybe like a 40 degree temperature. And then one of the rows mentioned that there is like a minus 100. This is impossible. This can't happen like within like a state like Texas, for example. So this is definitely an outlier. So here, as a definition of outlier, it's unusual or extreme value. This actually doesn't make sense if we look at the whole context of data. So now, again, we're gonna have another section. We're gonna explain the treatment of outliers more, but now let's focus just on how can we see if there is outliers in the data. So I'm gonna run the box plot. One of the methods that we can use to actually detect if there is outlier is to actually call the box plot function within the Seaborn library, which we mention is with SNS. So the box plot here, I just mention the X here, which is I choose here as a column the price. So I wanted to check using the box plot if the price column has any outlier. So let's see here, like when we got the output of the box plot, here it shows definitely that there is outliers because I have all my data. It's around this this price here, but then some data that it's out of that median value. Of course, when we go through the outlier treatments and also the univariate analysis, each information here gonna make more sense. But for now, let's focus on using the box plot as a way to detect outliers. So anything like out of these bars, which we call them the whiskers, it's actually considered as outlier. Another example here, maybe using the HP column this time, you can see it's the same thing. So this column also has some outliers, and also the same for cylinders. But for cylinders, it's less than maybe the HP or the price.